going to talk about rapid and accurate design of microstrip cross-coupled filters using Nuhertz filter solutions and AWR's Microwave Office and Axiom. We'll start with the filter solutions filter quick panel for very rapid initial setup. Here we have the geometry that we need to actually build the filter displayed to us by Filter Solutions. And here we have the layout view of what this geometry will look like. And over here we have the S parameters of the circuit simulation of the synthesized cross-coupled filter using the Filter Solutions Quick Optimize function. Now, to get an accurate electromagnetic optimized design, we need to go into the AWR control panel, select default configurations, Axiom, and now we're going to use these highly specialized tuning ports available to us with Axiom. This will be exported in this port tuning format for very rapid optimization. I'll select Overwrite to AWR, and you can see what happens. Everything's laid out nicely. Now I'm going to pull up the AWR Optimizer panel. Here we have the Axiom layout with the highly specialized prior mentioned tuning ports. These tuning ports will have tuning elements across the resonator separation and between the microstrip gaps. Here is the tuning schematic. The layout that we just saw is embedded in this block right here. The tuning elements exist here. These are microstrips. These will be used to fine-tune and optimize the microstrip lengths. These are admittance elements. These will be used to optimize the resonator separation. Here we have tuning equations. These will be optimized to control the tuning elements that we just saw. Here we have some equations. This will be used to adjust the admittance elements for optimal tuning. We're going to do an Axiom simulation. Now here we have the Axiom electromagnetic simulation, and you can see how closely it matches the Nuhertz circuit simulation. There is some error in the simulation, and that is due to the extensive amount of interactions in this layout that are very difficult to model. We have interactions here, here, here. Some of these are modeled successfully, but not all of them. So we do expect some error in the circuit simulation that we can see in the electromagnetic simulation. Now the real power will now be demonstrated here. I'm going to start the optimizer, and we will watch the Axiom simulation rapidly move to fit inside these optimization goals, S11, S21, by updating the tuning equations and the tuning elements. The layout will not be affected. So now we are getting effective EM optimization at circuits speed. And we can see our optimization constant reduce as we proceed. Now since this is small perturbation tuning, the first pass will only rough out the design. The second pass will fine-tune the design. Large errors produce large updates, tend to produce large errors. Small updates tend to produce small errors. So we will need a second pass, and we are all set up to do this. When I select this button here, import and re-export over, it will import the tuning variables. It will import the optimized tuning variables, reconstruct the filter internally in filter solutions, and export right back out in port tuning format. Like so. Now we can repeat this process. And you can see how rapid Axiom can simulate this structure. Done. Now here we can see the electromagnetic simulation after the filter has been reconstructed. And we can make arguments to say that this is an acceptable filter for final manufacturing, depending on our design requirements. We might be able to meet that. 15 dBs of S11 is pretty good. If we want to do better, we can make a second pass. And I will go ahead and do that by optimizing again. And we can see we're going to get much better results on the second pass. Okay, we'll stop right here. Now this time we're going to import and re-export over, but we are not going to use port tuning format. This will be in the final form. No tuning ports or tuning schematics. Now let's do an Axiom electromagnetic simulation on this final structure. And here we have the final layout. It looks like this. Here is the microwave office schematic with all of your geometry information in it that you need. And here is the final electromagnetic simulation of the optimized design. And you can see exactly how rapid and accurate this design process is. Thank you and have a nice day.